Hello, my name is Lane Myers and I'm the PD Pump Product Manager here at Ampco. And in this session, we're going to be discussing our remanufacture program as well as our premium economy product offering. But unfortunately, in the remanufacturing world, there are two words that run synonymously to each other, and it couldn't be more to the contrary. So I want to kind of clear that up before we get started with this. One is repair. A lot of people associate a repair with, maybe the pumps just limping along. They want to send it in. Someone will just give a paint job to it, change the bearings, polish out the wear, which will take away efficiency, and give the pump back. That's a repair. What we do is full remanufacture. As I'm going to go through this whole program, we say the body, cover, gear case, everything else is scrapped out, replaced with brand new components, machined back to new pump specifications, and reassembled to that of a brand new pump. Same efficiency, performance, warranty, everything the same as a new pump, just 2/3 the price. So it's a whole, in essence, you're getting a brand new pump back. So it's a whole different thing between repair and remanufacture. So the reason I bring that up is sometimes if you're discussing this program, a lot of the purchasers will follow that 50% rule, where if it's going to cost more than 50% the price of a new pump for the repair, they won't go with that. Well, remanufacture cannot be distinguished as a repair. So we want to make sure that that rule is not followed with this program. Because like I said, in essence, you're getting a brand new pump back. So in this demonstration, we are going to go through kind of our whole inspection process. I'm going to tear this pump down, show you what parts we throw away, what parts we salvage for machining, and then a lot of the upgraded parts that we put back in the pumps, as well as I'm going to try to show some of the typical failures you might see just by visual, looking at rotors, maybe how to inspect the pump. Even in line, I'll show you some of the things that you can do in the field as well. So the first thing we're going to do is you want to check for bad bearings. So here on the end of the drive shaft, pulley end, you want to put maybe about 30 pounds of weight and just see if there's any axial movement to that bearing. Obviously this one does. I can feel that moving up and down. You also want to try to pull it, see if there's any lateral movement. If there's any movement, obviously your rotors are now moving into the body and cover, and that's what's causing the damage. And your bearings eventually are going to seize up. So that's the way you can test the bearings outside of the pump. Second thing is to check for backlash. There should be zero backlash. When you engage that shaft, it should have immediate engagement to the mating rotor. So if you have any movement before it engages, most likely you have a bad gear, the teeth are bad, or it might even be that there's no oil in the pump. And the oil fills the gaps in those teeth. So if there's no oil in the pump, that could be causing that backlash. But that's something you can be checking as well yourself. Another thing, which is the number one failure of these pumps, and Jenny, can you show that picture on screen? If you walk into a plant and you have them remove that bottom plug, it's called a cleanout plug, that's what most likely is going to happen. This is the number one failure to the Waukesha style pumps, is contamination in the gear case. Many people don't even know what these holes are, so they're never removed. And the thing is, here's the oil chamber. This is just an open void. So when you constantly grease your pumps, all the excess grease is just going to drop down into this casing. And if you get any water contamination or any product pushing through that lip seal, it's going to start filling up into the gear case. Even water is going to float on top of the oil or the grease, excess grease. So now your bearings are right here. So now your bearings are going to be submerged in that junk, and eventually it's going to cause the premature failure of the bearings. So what we've done too, again, maybe monthly tell your customer to remove the bottom plug. Every month remove the plug, clean it out, put the plug back on and grease it. But you can see our competitor uses just a real frail plastic plug. And this thing's gonna break, either through using a wrench. You can actually use a screwdriver. It's just cheap plastic and it's ungasketed. Any water or anything gets in this gear case, you're gonna start contaminating the bearings. So what we've done actually for an upgrade is on all of our pumps, as a standard, new pumps and remanufactured, we use stainless steel cleanout plugs. It's gasketed and it's stainless, so you can take it on and off for the life of the pump, and it will not be damaged. But again, that is the biggest failure of all these pumps. So you want to be able to have these type of upgraded plastic plugs. But again, something you want to check when you're in the field. So now we're going to start tearing the pump down. Obviously in the States, we use on the Universal 1, ZP1, it's called a wing nut. It's powdered metal because it's meant to take on and off. Throughout Europe, you guys mostly use what's called an acorn nut. So the only thing I'd say about this is stainless steel. Not as forgiving as the wing nut, so you want to make sure that your customers do put a little never sees on those threads, just to keep, if they have like a universal one where they're taking it apart daily, they want to make sure they're not possibly cross-threading or eventually galling this up. So remove the cover. Generally, you're just kind of looking at the face, seeing if there's any galling here, where maybe a rotor moving out, any contact inside the hub bore, any damage. Now this one's all chewed up outside, so you can tell the customer pretty much had its way with pry bars, throwing it into a tank with cleaning, because it's even damaged outside of the O-ring. So this one looks more like an end user damage than actual system. So now we're going to look when we do the clearances. Now I'm going to check that there's 4 main clearances in this pump that we will check. It's going to affect efficiency. Now, I always say this, and I always get a blank look when I say this, but it's amazing how quickly the efficiency can drop, precipitously on a thin viscosity with these clearances. These pumps work to the 3rd power. So when your clearances open up, your efficiency is going to drop quickly on low viscosities. So if this clearance here and back face should be around 2,000ths, and now it's 4,000ths, that's 2,000ths more than the pump should be. So again, to the 3rd power, that's 2 times 2 times 2. This pump will be 8% less efficient, just like that. The clearances are very critical. So when we check the clearance, this is what's called OD clearance. So body to rotor to body. We're checking that, and we'll document what we're getting. Another thing is crossover. You want to make sure that the wings are going under the hubs, that the rotors are parallel. Because remember, we talked about the grease filling up in the gear case. That can cause, usually the bottom bearing is going to go first, because that's where all that sludge is going to be. So this rotor could be moving in and out, and that could be causing a crossover issue. The next and absolutely most important is the back face. So it is the back face of this rotor to the back of the body. This is the #1 clearance in the pump. And I've been doing this, embarrassing to say, but pretty pathetic career. But all I've done is 31 years with this pump. And I actually used to test pumps for about 4 years. And if that back face clearance is even a half thou out, it will fail. That is your #1 clearance of that pump, is back face. And then we'll check front face clearance. Not as critical, but we want to make sure the rotor is below the face of the body and see what that clearance is. Okay, so now we're going to remove the jam nuts. Obviously, you get a special tool sent with every pump that's contoured to the shape of the jam nut. And again, a jam nut is exactly what it is. A lot of people ask, what's the torque value? Well, I can probably maybe tell you, that's 45 foot-pounds, whatever. But generally, a jam nut, you're using a mallet and smacking it off. Remember, these pumps are meant to take apart daily, so that's mainly why it's done this way. Now, these jam nuts are a non-galling alloy as well. It's called Nitronic 60, and again, that's because the pumps are taken apart daily, usually in the Universal 1, ZP1. The ZP2s, now that's the longer duration pump. They have stainless rotor nuts that are torqued. And ZP1, that's the reason for these. Okay, so now we're going to remove the rotors. Now, noting that this is probably what makes this pump #1 in the world. I mean, this pump's been around for over 75 years. It's still the Cadillac of all the plants, the workhorse. But it's the rotor that really makes this pump so unique. It's the material. This rotor is what's called alloy 88. It's 73% nickel with molybdenum, bismuth, tin, chromium. Very expensive material. You also cannot weld this material. But this material is also called the material that moves, the material that glides. And it will never gall. So if you have this pump, if the rotor is buried in the back of the body, it might take a little more load, but it will go. There's nothing to contain. So just to show a few examples, when you're removing rotors, as let's say you pull this rotor out, and you can see this indentation right here.
When you pull the rotor out and maybe see something like that, it's a typical wear. But what probably happened is the jam nut came loose. So now the jam nut came loose, it's pushing the rotor outward, and that is the contour of the cover hub. So when you see that wear, you can tell the customer, look, you got to secure those nuts longer. Because remember, there's always going to be one shaft that's turning against the thread, and one nut, if not secured tightly, will run long durations of time before maintenance. It will eventually maybe come loose. The opposite, if you pull this rotor out, it's going to be a little harder to see. See this huge step right here, this big groove, call this the tree pan. Now that rides along the two body hubs in the body. And if you see a huge dig out of the tree pan area like that, that means the bearings are going. So what happens is, loose jam nuts, the rotor is going to come out. But when you have bad bearings, the suction of the pump will just keep drawing everything back. And it's just going to keep moving and moving and moving. Like I said, unlike stainless, this rotor will never seize. It's just going to keep going and removing material. So if you see something, a big dig, this right across should be 0 to 1 thou step. And you can see that is about, 15 thousandths, 20 thousandths. So there's a lot of wear on that. Another thing to look for in the rotors, sorry, put that down, is see this on the rotor face. So again, that is probably going to tell you either you got a couple options, either the bearings are bad and one of the rotors is moving, or a jam nut came loose and one of the rotors was moving. But what causes that, sorry, I'm trying to do this backwards, but when the rotor comes under the main rotor, oops, you can see how it kind of runs across there. And that's what's causing that digging. And then even on this rotor, you'll see a heavy burr. So it's pushing up the material. But that's what causes that. And it's usually means your rotors are no longer lined up with each other. One's moving out further than the other. And kind of lastly, if you ever see an alloy 88 very cloudy like that, real rough, it's usually some type of chemical attack against the alloy 88. As an alloy 88, now you cannot passivate this material. So if you have a stronger cleaning agent, or if they let the cleaning agent sit in the pump, it will start attacking the rotors. Okay. Now we're going to remove the body. Set that aside. The studs. Okay, now we're going to remove the bearing retainer. And when I was talking about water contamination getting in the gear case, this is one of the main reasons, the bearing retainer. Now this is the only thing that's protecting in there to go right into the bearings of this pump. So we have an upgraded feature to that as well. You can see on the competitor, they use this bearing retainer is made of powdered metal for Waukesha. And you can see even the crack here at 6 o'clock. And how that is done is when you're bolting it, if they bolt it unevenly, if they tighten this side more than the other, it will snap. It's that fragile. And that or it's just going to completely corrode. And again, this and the lip seal is the only thing that is protecting that bearing. So what Ampco has done, and again, it's kind of a double thing. Remember, we kept the gear case clean with stainless steel gasketed cleanup plugs. A couple more things. A standard feature for us is a stainless steel bearing retainer. It will not corrode, not crack. And we also have what's standard called a splash plate. So the splash plate will go right over top of the bearing retainer. Same bolt, nothing unique with it. And what it does is that a lot of times you might have a customer that cleans, has 1,000 PSI pressure right here and they're trying to clean the space. This splash guard takes the direct spray off of the lip seal to be a compromised water going right through the bearing. So it is a standard feature for us on new pumps and remanufactured as an upgrade.
Might as well bring this up. You might come across some of this. Removing the back plate here. A lot of times you'll see the customer might say, hey, my pump's leaking oil. And normally not on the top shaft drive, but on the bottom shaft drive, you might see a little oil trail here. So you can see that. What causes that sometimes, let's say a customer changes the oil out and they actually remove this back plate. Well, there's a couple problems that could happen. One, there's this keyway, and you got the lip seal. They come across here, there could be a burr on that key, and that'll tear the lips. But usually what the problem is they'll put the bearing, they'll put the back plate on like this. Here, bolted, and then they're done. The problem is gravity. Remember, these holes are not tolerance, they're just slot holes. So there's nothing holding the cover to line it. So if they put it on like this, the gravity, obviously the weight of the cover is pushing the cover down, which now all the contact is going to be on this lip seal to the shaft, and the lip seal won't even be touching the bottom of the shaft. So generally that is what causes it. So if anyway, try to keep it centered, or you put it together in horizontal way so you can get that centered. Washers. Okay. So here's the shaft cartridge. And obviously the shaft, the front bearing, bearing spacer, rear bearing. The nice thing about Ampco is we also upgrade the shaft. Our competitor uses 316 bi-metal shafts. So they actually friction welded. Actually have a friction welded where from this point on is 316. From this far back, it's just more of a carbon base. And you can always tell that if you try to remove a coupling on a competitive pump. Very difficult because it corrodes. And this is what you can get on high pressures or even fatigue. Eventually, all metal bends the same, which is how much we'll do that before the shaft breaks. So either high pressure or fatigue. The walk-shut shaft is fragile, especially with 130 and 220 size pumps that have a longer shaft overhang. Ampco's shafts are solid 1P17.4. So they have 4 times the tensile strength as a standard walk-shut shaft. So to me, all these years I could never understand. Walk-shut does offer 17.4, but with a price increase, and you have to request it. To me, this is a major failure point. So why would you have to request a part that is possibly a catastrophic failure? But for Ampco, that's a standard feature. Now remove the gears. Also another upgrade. Again, I've been doing this very, very long time, and Waukesha changed their gears from helical to spur about 20 years ago. And about every third pump that we take apart here at this facility, these gears are just junk. You can see the teeth are usually flattened, they're rolled over, a lot of chips are floating in the oil, the teeth are missing. It's just a very cheap gear. The Ampco gear that we use are helical gear. They have twice the load carrying capacity. They run much quieter. They're on an angle, so you always have more than one tooth engaged, larger teeth. These are actually round to size. Just, again, twice as good. Never, out of all the years, I can count on one hand when I've ever pulled a bad helical gear out of a pump. It's just running normal parameters, that gear will last you forever. This one, every third one you have to replace. Now, the nice thing is the diameter is the same and the bores are the same, so they are interchangeable. So you can pull a spur gear out and put a helical in. Okay, that's everything. Everything I put in the gray bin is everything that gets thrown away. Now we have gear case, the body, and the cover. That is all we salvage. So now we take the body and cover up the machine shop and remanufacture. We can remanufacture up to 4 times. So the standard pump, we will machine it in 20,000 increments. 20, 40, 60, 80,000 on the ZP1. On the ZP2,
U2, it can only be remanufactured up to 3 times. And that is just because of the location of the O-ring groove in the pellet bore, mostly for CIP. So that can only go up to 60,000, 20, 40, 60. So we can remanufacture that 3 times. So what we do is we put these parts in a vertical mill. So they'll sit, they'll go in location, we'll locate off the dowel pins. So everything is concentric to the shaft bores. We come down here with an end mill. We'll open up the impeller bore by 20 thousandths. We turn down the hub by 20 thousandths. And then we go down deep till cleanup. We might even only take 10 thousandths, depends on the back face wear. Then we reface it, send it for polishing. That body, that was junk, comes back looking just like a brand new pump. Same pump specifications, everything's the same. The only thing is it's 20 thousandths larger diameter. Same as the cover. Put that on, or open up the rotor hub bore, reface the entire cover, retrace the O-ring groove, and polish it. And again, you have a cover back to brand new specifications. The gear case is the only thing that we send out of our facility. We send it to a powder coater, which they will clean it. They bake it at 600 degrees just to get all the grease and oil out of the porous part of the casting, and then they powder coat it. It's a chip-resistant powder coat, better than the 2-part epoxy glue. Now that was my job starting right out of college in 1989. I painted these gear cases, and sometimes you can put a nameplate on it and stamp it. Just a hammer would chip the paint immediately. So it's a terrible paint, and you can see how it just rusts off, especially on the tops where there's no drainage. They're just going to peel away and rust. So ours are standard powder coat paint. Our standard color is FDA white. That is our standard. If for some reason your customer wants to maintain the wash-up blue, no problem. We actually have some customers that paint their gear case in red because they might have what's hot clearance rotors, and they want to know which pumps have a hot clearance or standard, so that we can request that. So I'm requesting any colors fine, but our standard is white. Then once all the parts come back to us, all the upgraded features, the bearings, the shafts, the retainers, gears, we reassemble the pump just like a brand new pump. Now we're back in the same procedures of a new pump. Same clearances, same efficiency, so you follow the same curves. Every pump is water tested, and you get the inspection sheet for the clearance charts, the flow rates, all that is sent along with the pump. And we get the 1-year warranty, same as a brand new pump. The only difference is it's 30% less than a brand new pump. So it is a great program. It's another thing too to do remanufacture. You have customers that wonder, well, is Ampco parts really 100% interchangeable? What better testimonial do you have with a remanufacture program is taking their pump and putting our components into their pump and performing just good or better. So it really gives you a better way of proving that yes, all the parts are completely 100% interchangeable, and these featured upgrades that extend the pump life. Also, what's nice with the remanufacture program is, let's say you can't, the customer doesn't want to go through capital expense, they don't want to buy a brand new ZP1 Plus or ZP3, but they like the conception of the idea of the front loading seal that Richard talked about tonight. We can upgrade your pumps. So if you send us an old U1, we can actually modify that pump into a ZP1 Plus, same as the U2 series. If you have an old U2 or ZP2 or a TRA20 and they want to try the new ZP3, we can take your U2 and modify it into a ZP3. So that is another opportunity to keep it as a maintenance budget and not have to go through an active Congress to get a purchase order for a capital expense. So that is pretty much our remanufacture program. Again, you send the pump in, we remanufacture it, 2/3 the price of the pump. Our lead times are 2 weeks. We also have a program called Premium Economy. And what that is, it runs parallel to our remanufacture program. So remanufacture, you send us your pump, we remanufacture it, and give it back to you. That's 30% less than the new pump. A Premium Economy pump, are pumps that we'll even ask you, even now, I'll ask you if you have a customer that you know has cores laying around and just gonna scrap them out, we'll buy those cores back. And what we do is we buy them back, we do the same process then, we remachine them, build them to full pumps, and then we stock them on our shelf. And then they go on our website for immediate sale. So if, you can even use it like an exchange program. You know, if a customer has, I don't know, 30 in line, it's the flow, maybe it takes instead of half hour to empty a vat, now it's taking an hour. They want to get that pump replaced, it's moving along, they don't have a backup pump. Well, you can look on our website. Yep, I need to know 30 when I have this tri-plant connection, top shaft drive, single O-ring seal, standard cover, standard rotors, and we will ship that pump. And then when you get it, if you want, you can always send their other pump back in exchange. And now that program is 25% less than a new pump, and that's because we invested in the core purchase. So again, it's a great program to take. And that also reminds me, we usually stock between 15 and 20 pumps, trying to get to 30. If we do not have a pump on the internet, if you're looking and I need to know 30 right away, but they don't have one, call Jenny. She's hiding behind the camera right now. But we have a lot of components that are machined as parts, and all we have to do is quick assemble a pump. So if you don't see it on the website, don't think we don't have it. We can most likely have all the cores for every size. Give us a call and we'll whip one up for you specifications. Even bringing that up, like rotors. I'm probably running long, but you got me up this early in the morning. So rotors, usually rotors are standard clearance. So again, remember the clearance is very tight. Anything under 200 centipoise, theoretically, there's no slip over 200 centipoise. So you want a tighter clearance. Now let's say you're pumping around 180 degrees, between 180, 220, and with a thinner viscosity. Some people might say, oh, you need to go to hot clearance. Well, if it's thinner viscosity, you don't want to do that because again, you're opening up the clearances by 2,000 to 3,000. Remember the third power scenario we talked about. So if you're doing something that's still 180 degrees thinner viscosity, you might want to purchase something that's called front face. So all we do is we take 3,000 to 5,000 off this face of the rotor. And all that does is protect you from expansion is going to go out. So when you're the shaft and all that expanding outward, this rotor will not go into the cover face. But that is the only tolerance that's touched. So you maintain high efficiency. That's just protected. But usually if you're going between 200 and 300 degrees, now you're going to ask for hot clearance rotors. And that is going to open up your hub, your wing ID, and wing OD and wing ID, about 2,000. And then the last rotor you can ask for is what we call hot chocolate. Now the clearances are open everywhere. Actually, hot chocolate rotor is going to be the same clearance as the stainless steel rotor. All your dimensions are opened up. Even the back face. Remember I said back face is number one clearance for efficiency. So if this rotor is supposed to have 2,000 back face, now it's going to be 5. So usually for hot chocolate, they're expecting like a plate in the peel where chocolate kind of plates back to the rotor. You're kind of building the tolerances back. You can also get a single wing rotor. That's usually more for particulates. We want to maintain the solids if you're pumping high fillings or anything like that. The only downside of single wing rotors is you can only run half the RPM. So these pumps are rated, they'll encourage it with a high rating of 600 RPM. A single wing rotor can only run the max about 250 RPM, 300, because of being, wobbling because all the weight on one side. But that's kind of the makeup of the rotors. I believe, but in the PE program, again, it's the same warranty. So it's the same as the remanufacturer. The same 1-year warranty as a brand new pump. Again, it is a fantastic program, especially those who just don't have the capital to fund. They can go through remanufacturing for the maintenance budget, and it really does answer a lot of questions, especially parts interchangeability, our quality, our service, our featured upgrades. It really shows everything. If you can't get a new pump in, remanufacturer is definitely the program to take advantage of. So I guess we'll kind of open up to some questions.
But for the t-shirt, I guess I'm gonna make up a question here, I guess, put in the chat room. Do we do it?
Yes.
In the chat box, I want the first person who can name me 2 of the upgrades we discussed that go into remanufacture. And all these upgrades we talked about also are standard in all of our new ZP1, ZP2, and 3. So if there's anyone who can type that in the chat box, you win the shirt. So Martin, I guess we'll open up to any questions, if there's any. If you have a question in the chat box, or unmute yourself.
Now we don't have any questions. I don't see any.
All right.
Oh yeah, we have one question. What performance guarantee does Ampco provide on remanufactured pumps?
What performance guarantee does Ampco provide on remanufactured pumps?
It is identical to a brand new pump. We stand behind that performance. The clearances that we do, so a remanufactured pump. Here, let me get. It's a good question because I missed that part of it. Once we make these bodies cover oversized, I missed this part. Obviously, we need to make the rotor oversized to close up those gaps. So now we got a rotor that's 20 thousandths larger. So you can see that that clearance is identical to a brand new pump. So we're going to bring, so even the clearance charts that are run parallel to your curves, they are going to be identical to a brand new pump. Your OD clearance, front face, back face, crossover, everything is identical to a brand new pump performance. So our warranty is going to stay firm with that. You will never see a deviation to the performance. Now, my advantage that since I have the floor, I'll tell you, years ago when I worked in Delaware, Wisconsin, we used to play with clearances. It was difficult in assembly the way you wash out machine things. They would run tolerances on the high end of the body, low end of the rotors. So your clearances wouldn't have any problems with assembly. Obviously, plus and minus 1, now you're expanding to over 2,000 clearance. Your efficiency is not good. In fact, we have the frac pump world that water tests every pump before they go onto the trucks. Waukesha pumps tested at 72% efficiency on brand new pumps. Ours on water, 94% on water, 1 cent a place. So our pumps, you're going to see better efficiency just because we're not playing with tolerances. We run everything on the horizontals, the tombstone fixtures, and that's why we can actually offer brand new pumps with stainless steel gear cases. Because we don't have scrap rate, we don't have long setups. We repeatability of our machines. We do everything on tombstone fixtures. All the machines, they know where these parts are. So you just put a part in, hit the program, it knows where everything's at. You don't have to run one-piece articles and everything. So just the different technology of machine allows us to make sure those clearances are held. And that's what you'll get with every remanufactured pump as well. You get a clearance chart of what was measured in that pump and the performance. Because again, on water, if those clearances are not held, you will not get a successful test. So every pump we stand behind will perform the same or better than that you had when you bought it brand new. That also reminds me too, the nameplates on the pumps. If you want to know if the pump's been remanufactured or what is the oversize, our nameplate will be 12345-R1-2, which means it's reconditioned once, and the -2 is 20 thousandths oversize. So it gives you a little understanding there. You might have a customer say, hey, what if I have a standard pump next to my remanufactured? Remember, everything is the same as a new pump, it's just out of the body in order oversight. So let's say they say, well, what if we interchange rotors? Can we damage the pump? You can't. You got a rotor that's 40 thousandths oversized. If they have an 030 right next to it, obviously that rotor is not going to fit. I know maintenance guys, they like big mallets, they might try, but it will not fit. Now they can take a standard rotor and put it into 40 thousandths over, and it will fit. Because we never change the thickness. The only thing we change is the outer diameter is thrown out, not thickness. We machine the cover, but we're the same depth. So the only thing that could happen here is
you're gonna lose some efficiency because you're gonna have an extra 10 thousandths or so on the OD clearance. So there's nothing that can be catastrophic and somehow messing up with that. Again, it's a great program and the warranty will cover you. So your efficiency question, no, it is, we stand behind that.
Okay, Elaine, we have a second question.
Okay.
When Ampco remanufactures a Waukesha pump, does the Waukesha pump get all of the Ampco upgrades?
When they remanufacture a Waukesha pump, does the Waukesha pump get the Ampco upgrades?
Oh, yeah. The majority, right, 90+% of all pumps coming into remanufacture are Waukesha pumps. So every component, all the shafts, the bearing retainers, the splash plate, the stainless steel, the cleanout holes, everything is going to be upgraded to, even though it's a Waukesha pump, it's going to be upgraded with a powder coat paint. The only thing that is going to look different, when the customer, we actually get calls sometimes, the customer calls and say, hey, you sent us the wrong pump, we want our pump back. You sent us a brand new one. No, it is your pump. It is a brand new pump. But all the Waukesha pumps will come up back with the same upgraded features. The only difference you'll notice between a Waukesha rebuild and let's say an Ampco, wish I had an Ampco cover, but you can always tell a Waukesha Universal 1 by the 2 cups. Ampco's covers are solid. So the only downside of doing Waukesha is this cover is a terrible design. What we used to do 30 years ago, and how we still do them, this cover is just a plate, just a metal plate with 2 holes bored out. These cups are 60 thou thick, and they press the cups in, and then they laser weld and polish them up. So when these cups act in, remember how I told you that a jam nut may come loose. So what this board in here is for is if a jam nut comes off the end of the shaft, it falls into that cover, and it's far enough where it gets off the shaft, so it's not screwed shut, and it just spins up. That's what the depth of this cover thing is for. The problem is the wall's only 60 thou thick, so this nut can eventually blow right through, which I've seen. We've got covers where the jam nut blew right through this. You can also tell end users, they'll put the cover on and they'll use the mallet and they're hitting the cups but with metal hammers. Now they're denting in these cover hooks. So that could even affect. So when we get them in, we have to rebend them out so there's no interference with that jam nut. Other than the cover, you are going to have every upgrade, the paint, the shafts, the pivot gears, splash plates, every upgrade we talked about will be standard, even on a Waukesha or a right pump. The right pumps, the TRA 10, the TRA 20, they have the same dimensions. We will fully remanufacture them as well. Thank you for joining us here this morning. Hopefully it was beneficial to you.